All right, so acids and bases. If you were not here at the beginning of class and you missed it, you have to finish the post lab. That's the back side of the sheet that I gave you yesterday. And then turn it in with your lab notebook, putting the post lab sheet, the pre and post lab sheet, in the lab notebook at the point in the pages where we did the lab yesterday, so I can compare your notes against what you turned in as your pre and post lab sheet. Then we watched this video. Okay, it's called Crash Course Chemistry, and this is the video on acids and bases. So if you missed any of that, it's your responsibility to go back on your own to watch. Okay? Now, we're talking about acids and bases, and he mentioned two different acid and base theories. We're going to start with Arrhenius because that's the one we've been working with. Yes.
In the video, he said that acid-base reaction was one of three reactions. But he didn't say that.
What? Acid-base one of three reactions. What? In what? You can go back and watch the video. That'll help you. Okay? So Arrhenius. Arrhenius came up with the idea, and Arrhenius was a contemporary of Bronsted and Lowry. Right? They were around about the same time. Arrhenius came up with the idea that an acid is anything that releases anything that releases a hydrogen ion in water. So this is an acid. Okay? An acid is anything that releases hydrogen ions in water. That's a really simple definition, easy to work with, but it doesn't cover everything. For instance, ammonia isn't covered by this. He said that bases are anything that releases a hydroxide ion in water. Yep. No, Arrhenius is the guy who came up with the definitions for acids and bases. Bronsted and Lowry also came up with a different definition of acids and bases. And then there's Lewis. We won't really get into Lewis much in here. But y'all remember Lewis. Lewis Dots? Yeah, that Lewis. Same guy. Well, a hydrogen ion means H+. So let's review a minute. What is in a hydrogen atom? What's a hydrogen atom made of? One proton and one electron. That's all there is. To get a plus charge, how do we get a plus charge for that hydrogen ion? If I have a plus charged proton and a negatively charged electron giving us a neutral hydrogen atom, we're going to get rid of the electron. That's right. So if the electron goes away, all we have left is a proton. Hence, a hydrogen ion is a proton. Hydrogen ion. Okay? A hydrogen ion is a proton. Got that? That's really important that you understand. And then when I say hydrogen ion, you think, oh yeah, that also means proton. And if I say proton in the context of acid-base chemistry, you also think, oh, that's a hydrogen ion. Okay? Got that much? No. And what is it that confuses you? Hydrogen ion is a proton. Boom. Stop making it hard. The reason we get a hydrogen ion being a proton is that a hydrogen atom is made of one proton and one electron. If you get rid of the electron, all you got left is a proton. Therefore, a hydrogen ion is a proton. Is that hard? That's kind of like first grade math or something, right? Kind of, sort of? Third grade math? Okay, third grade math. She agrees. All right. All right. What's a hydroxide ion? Well, if you don't know what a hydroxide ion, where would you find it? Huh? Test references. Find the hydrogen ion. You need to know what I'm sorry, not hydrogen ion. Hydroxide ion. What's a hydroxide ion? Find it. OH negative. Okay? This is a hydroxide ion. All right? If I put a hydrogen ion and a hydroxide ion together, what do I get? Neutral. It would be neutral. H2O. What is that? Water. That's why when you put acids and bases together, you neutralize each other. That's yesterday we neutralized two kind of acids with a base. All right? Because we're putting hydrogens and hydroxides together, and we get got that? If we put 3 hydrogens and 3 hydroxides together, we get 3 of these, and we get
milk.
This is milk, really?
Hydrochloric acid. Milk. Oh.
Ho, 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 ho.
My gracious, guys, come on, wake up! All right. Well, last time I read it, it was only ho, ho, ho. But okay. All right. Anyway, back to acids and bases. Back to acids and bases. Yesterday we were working with this acid. What's it called? Hydrochloric acid. If I have hydrogen chloride in a pure form, it's a gas, and if I mix it into water, all right, so I'm going to dissolve it in water, I'm going to get hydrogen ions, and I'm going to get chloride ions, and because we release the hydrogen ion in water, whoop, I'm going down here, come on, work with me here, there we go. I mixed it in water, released the hydrogen ion in water. What are we getting? There's our acid. That's why it's an acid by Arrhenius. Got that? Why do you keep saying no? Really? Look, by definition, Arrhenius says an acid is anything. Be quiet and listen. Arrhenius says an acid is anything that releases a hydrogen ion in water. That's the definition he gave, right? Yes or no? Yes. All right, down here in the equation, did hydrochloric acid release a hydrogen ion in water? Yes. Really? What's so hard about that? Really? You got it now? All right, just let it kind of sink in. It'll be all right. I promise. All right? Maybe you just should stop saying nope automatically. All right? And think a second before you say it.
I'm writing. I can't do both.
Oh, yes, you can. Yes, you can. I know it's difficult, but it's something you need to learn to do. All right, now, we also used a different acid, right? What was the other acid? Acetic acid. H, CH3, CO2. All right? When I put this in water, and this is actually, you can actually dissolve acetic acid in water and not have it break up. But in water, if I put it in water, it's going to break up and we're going to be able to make a hydrogen ion. That's what makes it an acid according to Arrhenius. So I've given you the example here. Now you finish this equation. If I break this up into separate ions, one of them must be a hydrogen ion because that's what makes it an acid. Write the formulas over here. Predict the formulas over here.
First one was a lot easier.
This isn't that hard. Don't make it hard now. Just think it through. Don't automatically give up. Think it through. What's it going to do? Follow a pattern. Show me. I'm from Missouri. Show me. Don't get distracted by this. Do this. This is your assignment. Good. Well, she said she did it. Okay, Daisy, what's the first thing I'm going to write right here?
That's what I wrote. I wrote H2H. That's not right.
In order for it to be an acid, what does it have to give up in water?
COH. C2.
No, hydrogen.
What?
Listen carefully. What's it have to give up if it's a hydrogen ion, or which we also call a proton. A hydrogen ion is a proton. Well, if I pull H off of this, what do we have left?
CH3CO2.
Okay? But that's not the end of that. You've got to come up with something else to finish this. It is going to be aqueous, but there's still something else. This doesn't have a charge written on it, right? This has a charge written on it. What do I need on this to make the charges come out to be zero over here?
No, you need a coefficient 3. No, I'm joking. Seriously.
You gotta be.
Name this ion. Write it down on your paper. Look it up on your test references and write it down. Don't spell it for her. You look it up on your test references and write it down.
I can guess.
Don't guess. Look it up on your test references and write it down. What?
I was gonna have to like go back to balancing equations.
Yes.
Oh, no.
I told you this class is, once you learn to balance equations and the stoichiometry stuff, that's for the rest of the semester.
I still don't know how to do that.
Then you need to go back and review or come in and get help. I'll be glad to help you with it. What?
We need to name that.
Yeah, just put a name underneath it. Write it down. Don't tell people what it is. Let them look it up for themselves. Make them use the test references they so vigorously resist using. I'm trying to help you pass the test by making you practice with something you should be willing to practice with because it'll help you on the test. All right. What's the name of it? Acetate. Acetate. All right. Now, so we put these acids in the water with something else to neutralize it. What was that something else we put in the water with yesterday? Formula? Formula? KOH. That's potassium hydroxide. Now, you weren't there when I made the solution up, but this was a solid. And I'm going to put that into water. Okay? And based on what you observed in the lab yesterday, when you got out the potassium hydroxide to neutralize that acid, what state of matter was it in?
Liquid.
Well, it was a liquid. It was aqueous. It was dissolved in water. Very good. All right? So, to make it a base, what part of this formula do we need to have separated by itself?
The hydrogen.
The OH, because that's what we set up here. Anything that releases a hydroxide ion in water, right? And I said right here that's OH, there's hydroxide. So we know we have to have a hydroxide ion over here, and it is aqueous, okay? So what else are we going to put down here to finish this equation? Finish the equation. Huh? Look it up on the in the test references. Hydroxide has a negative charge. Because Arrhenius said anything that releases a hydroxide ion in water is a base. So we know we have to have a hydroxide. Well, some bases don't actually directly release the hydroxide, but in this case I'm telling you it does. Okay, it is. It's right there. It's in the formula. At this point in time in the semester, you should be able to recognize OH just by sight. What? Okay. Let's try to get over that. Okay, y'all didn't hear it. He said he was kind of playing around. He said OH isn't on there. Then he said I lied, and I said no, try to get over that. Just a joke. Okay. Never mind. If you weren't paying attention, I know it. I'm telling you. Okay, here we go. What else do I have to have here to balance this formula? This equation, rather. I have to have a K. Need a special K there.
Yes.
Which kind of K do I need?
You said special K.
Has to be positive. And Alex, why does it have to be positive?
Because the other one's negative.
Yeah, so if I'm going to neutralize this and make a neutral compound, this has got to be positive, and it must be dissolved in water, so it's aqueous. All right, so this is what we're working with yesterday. This is what we're working with yesterday. This does not tell you what happened when you neutralized that acid yesterday. Okay? What we did was to put this stuff, which I dissolved in water, with this stuff, which I dissolved in water, to neutralize it. Okay?
Are we always dissolving water?
Most of the time in high school chemistry, acids are going to be dissolved in water. You can dissolve in other things and still be acids. But we're not going to do that in high school chemistry.
Because they're dangerous.
No, it's just that we don't do it in high school chemistry. We're not doing, unless you're taking organic chemistry, in which case you might do it in something else. But in high school general chemistry, where you are right now, this is the way we work with acids in water. Okay. All right. So what we have is actually this stuff, because when we actually put it in water, it became this stuff. And what we actually had when we put this in water was to make this stuff. Okay? So let's put all of this stuff together with all of this stuff, and let's see how we neutralize our acid. Okay? So make an equation where this is on the left side, and this is on the left side, and let's figure out what goes on the right side. Make an equation where all of this is on the left side, plus all of this is on the left side, and let's figure out what goes on the right side. Write it down. Put all of this on the left side and all this on the left side. Because what we did was, when we neutralized hydrochloric acid, we used a potassium hydroxide. They were both dissolved in water, so they're both of them are in this stuff right here. Let's see what happens. Yes, you can. Don't tell me you can't. I know you can. That's right. You can do it. You can do it. Can you write down this plus this plus this plus this? Can you write it down? Okay. And then you have to figure out what might go on the right side. Huh? How do you know? What do you know? Yep. This plus all of this on the left side of the equation. And then we're going to figure out what goes on the right side of the equation. What?
You call me an idiot. That word really rhymes like idiot.
Don't. Listen. Nobody in here is an idiot or a stupid or anything of that sort. Okay? Alex, nobody in here is an idiot or stupid. Okay. Okay. That's enough. I didn't ask for discussion. I didn't ask for denials. I asked you to listen, and that's all I ask you to do. Okay? We don't do that. All right. Everybody got it written down?
Yes, sir.
H plus aqueous plus Cl negative aqueous plus K plus I said to write all that plus OH negative aqueous, and now we want to figure out what goes on the other side of the arrow. They're all dissolved in water. Huh? What about the arrow? No. We're going to see. We're not talking about aqueous says it's dissolved in water. We don't have to worry about that.
You're going to have HOH COK.
Oh my gosh! These are going to go together. So we're going to get HOH, and plus we're going to get this Cl ion, and we're going to get this K plus ion left over, right? So what physical state are we going to assign to this?
That's going to be aqueous.
No. That is a liquid. Water doesn't dissolve in water. Water is water.
Oh.
It's a liquid.
Oh, yeah, that is.
That's how we neutralize the acid. We made water. Which is a liquid, but not all liquids are water, okay? Okay, that's a very good question. Why didn't I combine potassium and chloride? I could, but if we're in water, they stay broken up. Okay, you didn't see anything settle at the bottom as a solid, did you? However, if we took our neutral solution and we evaporate all the water out, we get a white powder, which would be this stuff. So we could get them to go back together. Well, what did we do? Think back. Scratch your head here, rub your beard here. Let's think back, okay? When we had an equation like this, where we had, you got to listen. You got to listen. You got to listen. Got to pay attention. You got to have your eyes up here. All right. When we had equations where we had exactly the same thing on the left side and the right side, what did we do with that? When we wrote equations earlier in the semester where we had ions on the left that were exactly the same as ions on the right, what else did we do after that?
Cancel them.
We did cancel it. So this then is called, has a name, this kind of equation where the ions that don't do anything, they have a this kind of equation has a special name. What was the name of this kind of equation?
I know what it is.
Double.
No, it's what is it?
All this.
That's in my notes.
We got irrelevant ones.
Huh?
Double replacement.
Well,
No.
this is actually a kind of a double replacement reaction, but I'm thinking about the name or classification name of this kind of reaction, this kind of equation here. We wrote equations where we had these ions that didn't do anything in them.
What year was it in?
I don't know. Be about 4, maybe 5.
It's not that ionic.
Huh?
Spectators.
Those are spectator ions, but what kind of equation? What kind of equation?
It's a net ionic.
This is a no. This is not net ionic. Close. Close.
Complete ionic.
Complete ionic equation.
Complete ionic.
Okay.
There you go.
What's that? I know if we have our notes.
All right. Now, if we take out those ions that are exactly the same on both sides, then we get this. H plus plus OH negative and on the other side we get HOH. And this is the net ionic equation. Somebody mentioned this a minute ago. Okay? So, What we're doing here is we're just looking at how it is that we went about chemically neutralizing that acid yesterday. Okay? So let's review real quick and we'll move on. Arrhenius says anything that releases a hydrogen ion in water is an acid. Hydrogen ions are essentially protons. And for hydrochloric acid, we put it in water, we get hydrogen ions and chloride ions. Okay? That made it an acid right there. That's what makes it an acid. Okay? We neutralized it with potassium hydroxide in water, which became potassium ions and hydroxide ions. So that's just when they're dissolved in water. There's two separate solutions, okay, that we mix together. When we mix them together, we put all those ions that are in water together, and we get this complete ionic equation here. And then when we break it down or simplify it down, condense it down to the simplest stuff, the net ionic equation shows the way that you neutralize this kind of acid, this kind of base, is hydrogen ions that are in the water join up with hydroxide ions which are in the water and become water. Got that? It's a lot of stuff out there. But we had to do a whole, like 3/4 of a semester to get to this point so you can understand that. Okay, and this is the simplest of the acid definitions. Got it? Don't say you didn't understand it. Just use your brain and soak it all in. You can. This I can't or I don't or, no, that's just like giving up before you start. All right. Now, that was Arrhenius. Now, Bronsted-Lowry. Bronsted-Lowry. Whoop, I just can't seem to write Lowry today. L-O-W. Bronsted-Lowry. So let's break this a minute. I'm gonna stop capturing here.